Okay, let's get started. Okay, hi, my name is Qixiang. Today I'm going to introduce why and how we're going to distributing our agent. And this is our latest work, Ragent. This is a scalable AI agent framework that built upon Ray. So let me do a quick intro. I'm from On Group. As the robot has said, we are the first serious user of Ray. Alipay is ours. Work for the Ray team. We are the second largest team, contributing more than 26% to the record code. And for now, there are over 1.5 million CPU cores that are stably running online. So that's quite a large scale. And also, we are operating the Ray China community. So our team is created in the 2017. And in the very next year, we found our first scenario. We built the Gflow upon Ray. It's a streaming graph engine. And during the big data area, during 2018 and 2022, we built a lot of engines and deployed in many scenarios, including streaming and machine learning training, and online inference, scientific computing, and also contributing to the multi-tenant architecture. In the large language model area, we built a unified AI serving. That's our last year's topic. And this year, the latest work is AI agent framework. Let's do a quick intro to the background. So what is a LLM-based agent? So we think it typically requires 4 modules. So number one, the profile is where the user customizing the personality and giving the agent a mission using like system prompt. The number two is memory. It contains the knowledge and experience, like what the agent has done in the previous steps and how it end up with. And the third is planning. That's to split an intricate task to simpler subtasks. So this involves many strategy or algorithms like chain of thought, react, or other strategies. So the fourth is action. This is where agent take effects to the real world. So the function calling is a part of the action. Agent will utilize different tools to do different actions. So let's go through those concepts with the naive RAG agent. So again, the RAG is not in the traditional way, but in the agentic way. So at first, we got an agent, right? It has memory, several tools, and a certain strategy. So in the first step, the agent is going to observe a task from the user, like please learn from this document. And the agent starts thinking what to do in the process of the React strategy. It gives a thought like it should pass and load the document to the database. So the next step, the agent will utilize tools to take actions. So in the RG scenario, there are so many tools should be involved, like the Llama index or LangChain is used for processing the documents as part of the knowledge. Those are typically the computation task, which is CPU intensive. And also, you need Lucene or VectorDB for retrieving those documents. So Lucene for lexical search, and VectorDB for semantic search. Oh no. And also, you might need some search engine like Google or Baidu for getting real-time news. So this is the network accessing because that's all the external services. So in this scenario, agent will decide to use Llama index and the VectorDB and do the action, which is indexing the documents. So after getting the result, the agent will put its initial thought, the action it chose, and the result as a triplet into the memory, and repeat the above steps until the task is completed. So after you get the program, the next thing to do is you deploy it. It's very simple. You're exposing as a service, wrap it in a pod. That's how we do. At the very first place, we are building an agent crafting platform. That's where our developer crafting their agent and publishing. So by now we have like 500 agent apps running on top of those platforms. The codes or model scope are the same way. But we've received a lot of user complaints because it's such a simple way, right? So the complaints can be concluded as they need to be productionized. Like the first one, I have no idea why my app or pod is dead. There's no matrix. And also the GPU utilization is pretty low on hybrid workload because those workloads are just put in one pod. That's naive. So we're going to do the productionize, but we see a lot motivation. We reckon that agents are very unique in different than the other tasks because agents are very creative. The first one, there are constantly emerging innovative ideas, and I believe this is also why the agent concepts going so popular in recent years. And number two, those ideas should be quickly validated with the lowest cost. That's also one of the golden rule of commercial rule, especially for startup. And the third one is pretty important. I want to emphasize is that's because many of our Android users start in this phase because it should be very easy to convert my local code, my proved ideas, to the productional environment. But this step is pretty hard. In a nutshell, it can be short to as you have to drink a lot of coffee with many team leaders because when you are writing a real productionized application, many teams should be involved. Like in the RG agent, you should have a team for data processing, Kubernetes runtime, GPU resource management, and some computation engine team like Spark or Flink. These are just a minor one. One of our agents involves 6 teams. That's already good for him because he can summon those teams. Many of other Android users could not summon a team. So they pretty died on this phase. Can't drink those coffee. And the first one is the task is pretty hybrid. The GPU, CPU, and service calling can be involved in one user task. So you can put them into the one pod or using a traditional computation agent like Spark because it's low efficient to do the service calling in Spark. You need a pretty dynamic engine. So let me just jump over those Kubernetes launching and jump direct to the solution. We're going to use Ray. Why? Because Ray provides one stop for AI workload, and it's very easy to scale the local code to distribute. Those two items are the vital important in the agent scenario. And also heterogeneous resource scheduling and other stuff, also the reasons we choose that. And once we use Ray, there's also extra points, like the runtime env is a perfectly matched to the code interpreter because code interpreter need a runtime sandbox to run those autonomous user codes. Runtime env can do that. And Ray's object-oriented programming is a natural fit for writing agent because we reckon that agent is kind of an object. The agent has its profile like the static resources and the memory and some sort of runtime state, and action is sort of the member function. So we can feel like it's like writing an object, writing a class. So after using Ragent is obvious, we should have a framework to provide the agent domain API and utilize Ray to scale those code. And the third one is unique is that in the multi-agent domain, you need a component to orchestrating those distributed multi-agents. And the first one is for the adaptation because you need to compatible to those interesting libraries such as MetaGPT or AutoGen. Those are the library our upstream users would like. So we designed the Ragent. Let's first take a look at look at the location of Ragent in the software stack. From top to top down, the first three layers is the first one is the business layer. That's where the agent apps are. And the next layer is the agent crafting platform like codes or model scope. And what's next is the agent algorithm library such as LangChain, MetaGPT, AutoGen. And the Ragent is the next layer. We're providing the distributed agent SDK. It provides ability like tools, distributed memory, and the necessary components for model agent and deployment. And the Ragent directly using the ability from Recore. That's the main source. We're using the ability of like task, actor, and object. That's enough for building an agent. And the read data are mostly for the tools. Those tools including processing documents. Those are the batch processing. And the reserve is to expose the agent. That's the way you provide the service of your agent. And Kubernetes is in the very bottom. So when you're programming, when you want to write an agent, the Ragent gives the basic agent. It provides some basic abstraction and the necessary ability to physically communicating agent. In this, the Ragent will deploy the user agent as a reactor. And as I have mentioned, there's different kinds of strategy. We have a built-in strategy implemented using React. That's sort of like you think, you act, and repeat. So the React agent has already, you can see there's a while loop in the right line. This while loop, and the agent will keep thinking and do the action until the task is complete. And this agent is enough for some simple scenario, for some simple agent, where all you have to do is register some necessary tools to the agent, and the agent can start using them. That's the agent. And another, as I said, you have to register tools. So we have the abstraction and built-in tools. For example, in the RG scenario, you had to write a function to indexing those documents. So in this square, we are implementing using read data. And once you have wrote down the functionality, you have to using an annotation to describing the functionality and also the input and output. And then registered. After registration, the tool will be elaborated by the agent and will be the part of the final prompt that fed into the model. Okay. After you got the get the agent and register some tools, you can start writing an agent. So let me show you how to write an RAG agent in very few lines. So in the first line, you're already initializing an agent using our built-in React agent, right? And you are assigning the profile. What's inside is you are giving a language model. In this case, we're using Chen model. Also, you can switch to the GPT-4o. And after that, you're ingesting some tools, including the first one, indexing document using Llama index, doing the semantic search, lexical search. Then you can start to query. It's already enough for the agent. So the very first task is to learn from the doc we're giving is the latest documents. And the agent will think it will utilize tools and utilize the index tool, and the action is to submit the job. In this case, as we implemented using read data, this will submit the read data job, and the job will running in the same read cluster with the agent itself. So once you have learned from the document, then you can start asking question about the document. So like what's the RADP in 3.0 version? This will trigger the traditional RG processing. So that's the single agent. this case is more interesting. The multi-agent application. So the left picture is a MetaGPT. It's a very interesting project. You can search on the GitHub. So the mainly we're focusing on the multi-agent to collaborate to write a game. They are sort of starting a company, and the different agents play different roles, such as one for production manager and another for architecture, and also, of course, engineer and do the QA test. So we have implemented this case in the Ragent. First, we implement the environment that's a global component for orchestrating those agents. It has task tracing ability and the message queues for communicating and the dialogue history, and also those remote handlers of all the agents. So in the code, you initialize the environment, and after that, the arrow. After that, in the purple code is the MetaGPT's code, and they had to be sort of wrapped into the Ragent domain. So we wrapped in the MetaGPT agent class, and then they can be joined into the environment. Means the handler are sent to the environment, and the channel are built. And after you run the environment, the agent can start to work. Like you give the command to the environment, please write a snake game, and we have tested it on the GPT-4. It can output the diagram, design diagram, user requirements text, and some code and unit test. So that's a multi-agent application. That's what we have done so far. And our future work is, those agents are all running on top of the Rig cluster. But for now, different agents with different library cannot communicate with each other. So what we are trying to do is we make an agent protocol so that those agents running upon the cluster can communicate with each other, like AutoGen, MetaGPT, and the recustomized agent. They can all be unified. Oh no. And another agent work is we're building an online and offline fusion architecture. Actually, this is already done in the Ant group in the other scenario, but not the agent scenario. Since the agent for offline work and online work can running on top of recluster, and those are, as I have shown, those are tasks. You can submit data tasks. These are offline. So they're also all running on top of recluster. So why not? We given a really big cluster that can running both online and offline. I won't go through the details, but that's what we can do. We're trying to do the online and offline fusion architecture. Okay, I think that's enough. That's all. Please contact us. This is my WeChat, and the left is the right code is our China community's WeChat code. Okay, that's all.
All right. For the Q&A section, if you have any question, please raise your hand, and I'll pass the microphone over.
We're gonna open source in the end of this year. I was planning to open source in the few months ago, but I have some distraction, so this end of the year.
Who else has a question?
Can you elaborate more about the multi-agent apps? Since there's no communication amongst the different agents, what's actually going on there?
Okay. In the very first, I have to demonstrate that this work is from the MetaGPT, it's not ours. So in this case, there are 5 agents. The first for product manager, that's the first agent that receives user's task. And after he saying user want a snake game, it will utilize its own tool, like the diagram tools for diagram. And after output the diagram, the very next agent architecture, he will analyze because he know what's upstream. he will pass and analyze those diagram and transform to the format for the following agents. And afterwards, project manager gives a exact task, and engineer start to coding. And in our test, the very first few rounds coding are pretty bad, and they cannot even run into the unit test, but it should be better in the few next rounds. So they will repeat the whole process. But for now, you should pretty stop the whole process yourself. We have tests on different large language model. For now, only the GPT-4 can do such thing for some simple program. So any other question?
Yeah, hi, great talk. My question is, if we stay on this slide, what do you think are the role of data streaming technologies like Kafka in this multi-agent communication or just development of agents?
Your question is what type of data streaming tools used in this case, and what kind of other tools for communication?
Yes.
Okay. The streaming tools are the part of the data ingestion. They are included in the tools. So in my case, I give the example of read data, and we have one tool using the read streaming, ant group read streaming, and it consumes data from also our data source. Yeah. Okay.
Yeah, I'm very interested on your offline batch inference.
Offline batch inference, you
The
mean?
last slide.
Okay. You mean the right part?
Yes, because for online is you deploy as a service, right?
Yeah.
For offline batch, how do you scale it up?
Oh, you mean the offline job, how to scale?
Yeah.
Those are the responsibility of read data. Yeah.
Any other question?
I believe.
But wondering if there are any challenges that you guys have met building this tool. Can you share one or two?
Your question is what challenges we are faced building this framework? Yeah, that's pretty a lot of challenges. Apart from the algorithm, that's the responsible of the long chain and llama index. In the productionizing, one thing is the agent protocol. For now, there's no standard for how agent communicating. I've faced a lot of problem because AutoGen implementation has a huge diverse from MetaGPT. So when adapting them, there's tons of work to adapt them. That's one. And also the memory format. When you in the multi-agent scenario, it's vitally important to how you construct the memory format because different agent has their own context. You cannot build a very long context of the memories so that you wish all agents can understand. That's not true. So you have to dedicate those agents for if there are 10 agents in an environment, you should build first memory format for the 3 agents and another format for the last agents. So the agent memory format is important. Yeah. What's that? I'm not here.
You mentioned the different format agent communicates between each other. Is that the major difficulty in agent protocol?
The dedicated protocol of multi-agent interaction.
Yeah.
You can. I would introduce you a project called Agent Protocol. You can search on the GitHub. That's defined the interface pretty much like the RESTful interface. It declared how agent can step forward and what's the interface to interact with each other agents. So it gives pretty much interface like the protocol, agent protocol. Okay, sir.
That's pretty impressive. In one of the earlier slides, you mentioned that there's a whole suite, a library of 500 agents you're trying to enhance.
Yeah.
What's your method of distribution for that? Do you have a pit package for this? And how are you deploying them for
You mean this picture?
Yeah, yeah.
Yeah.
How do you get people to submit new agents for you?
In the previous, it's in the traditional approach, the naive approach, the left part. And I want to emphasize that those agents are pretty innovative and very interesting. And for giving an example, there's a data discovery agent and deploying it this way. And once you are feeding into the very large documents to ingestion and to understand, the agent will enter a state like fake that because CPU are high load and the risk of out of memory. So the part of the computation should offload to the other node that has more CPU. That's one of the motivations. So we use Ray and we submit as a remote task to the CPU node. And in other discovery scenario, you might need to use GPU, and the GPU cannot be deployed in the same pod as the agent. Also, they will be submitted to another pod. That's how we observe that kind of.
UI team would like let people submit prompts and documents?
No, it's a setting. It's also an interesting part that the last talk about launching, they said the UX is part of the challenge for agent. We're also facing that. We don't have now a friendly UI. So right now, what we're providing is a canvas where you can dragging all those components together and dots and lines, connecting them. That's the way. Okay. Oh, what's that? Sorry.
Do you define the set of different tools for users to choose from, or do you allow them to customize their own tools for the agent?
Do I prefer to customize, like users to customize their self-agent, or I prefer to use our agent?
Yeah, so I think you mentioned that there are a bunch of different tools, for example, vector search and different stuff. So do you provide them as a predefined set of tools, or do you allow users to?
Okay, I'm glad you asked. That's a part of the tool. This is the way you customize your tool. And we also have many built-in tools. They are mostly coming from the launching and Llama Index. And the one thing you can do when you're customizing tools is you can do such you can use read data for processing data more efficient than you doing just using local library like launching. So there are two ways. We have a library, built-in libraries, and this is the way you're customizing.
All right, guys. If you have any more questions for speaker, please. Almost out of time. All right, one last question. Yeah.
Okay, so.
So you evaluated or compared different frameworks like blockchain. So how confident your team about using Ray for this agent?
Your question, how confident I am to compare my framework to the launching. I should repeat this architecture. We are not competitive to the launching because they are our library. They provide the algorithm. Our framework is aimed to distributing those agents. We split the agent itself into multiple components and distribute it to our cluster. And as for how you make an agent better, how you giving the accurate answer is not part of our job. It's the launching's job.
All right, thank you so much, everyone. If you have any more questions, you can ask the speaker right after the talk, because we are running out of time. Have to set up the next talk. And please, with a round of applause for Qixiang.
Okay, thank you.
all.